Assalamu alaikum and welcome back. Today we will solve example for expected value of functions of random variable, and we'll start with example 3.18 from your book. Okay, in this example x we have a random variable x, and the sample space of x is given as -3, -1, +1 and +3, and we know the PMF of x as well, okay, which is 1/4 for all values of x. So it's 1/4, 1/4, 1/4 and 1/4. So our values are equally likely, right? And we are given a random variable z, which equals 2x plus 10 whole squared, and we are required to find the expected value of z. Now we're not given the probability mass function of z. However, we know that from the probability mass function of x and using the relationship between x and z, we can find out the expected value of z, right? And the way to find out is the summation over all possible values of x, 2x plus 10, the relationship between x and z, the function, multiplied by the PMF of x, will give us the expected value of z. Okay. Now the rest is easy. Just replace all values of the PMF. So so the first value is 3, so it will be 2, first value is -3, so 2 into -3 plus 10 whole squared into 1/4 plus 2 into -1 plus 10 whole squared into 1/4 plus 2 into 3 plus 10 squared into 1/4 plus 2 into 1 plus 10 squared into 1/4. If we solve that, we will get the expected value of z, right? There's also another way, that is, we know that expected value of z, we know the function of z, so expected value of z is equal to basically expected value of 2x plus 10 all squared, right? So let's open this bracket. So this will be equal to expected value of 4x squared plus 40x plus 100, right? And expectation is a linear function, right? That means we can take the expectation inside and apply that individually, right? So this can be written as expected value of 4x squared plus expected value of 40x plus expected value of 100. Okay, another thing to learn, whenever there's a constant multiplying a random variable, okay, the constant can be taken out of the expectation. Okay, so expected value of 4x squared can be written as 4 multiplied by expected value of x squared. Okay, and similarly it will be 40 multiplied by expected value of x. Okay, now what will be expected value of 100? 100 is a constant. Okay, it will always be 100, right? So obviously the expected value of a constant is the constant itself, right? So expected value of 100 is 100 itself. Now we have to find the expected value of x squared and expected value of x, right? So that will be easier. Expected value of x squared can be found out. Again, the same formula here. So it will be the first value of x, which is -3 squared into 1 over 4 plus minus 1 squared into 1 over 4 plus 3 squared into 1 over 4 plus 1 squared into 1 over 4. So this will be 9 plus 1 plus 9 plus 1 divided by 4, which is 20 by 4, which is equal to 5. Okay, and then expected value of x, right, is similarly minus 3 over 4 plus minus 1 over 4 plus 1 over 4 plus 3 over 4, which comes out to be 0. Right, plug these values back to this equation, and we can find out the expected value of z to be equal to 4 into 5 plus 40 into 0 plus 100, which is 120. Okay, if we had done all these calculations, that would also give us 120. So both ways are okay. Just this way sometimes it's easier, however you can do it anyway, and that will be all right. Okay, let's do another example now, and that is the example 3.19. right, so example 3.19 from your book. Here x is a binomial random variable. All right, so x is binomial with n equal to 48. So there are 48 independent speakers. All right, and probability of each one speaking is 1 by 3. So p is 1 by 3. So if this information is given, we can find out the PMF, the probability mass function of x, right? So the PMF of a binomial random variable, we have already seen it, is just n k, okay, p to the power k 1 minus p to the power n minus k. Remember that? So if we know the PMF of x, we know we have to find the expected value of z, which is given as x minus m plus, where m is equal to 20. So if more than 20 speakers are speaking, there will be a drop of packet. All right, so whenever x is more than 20, the plus means only the positive values of this number. So if x is less than m, x minus m will be a negative number, z gets 0. So this by definition, right, equals 0 whenever x is less than equal to m, and this is equal to x minus m whenever x is greater than m. So whenever x is greater than 20, the value will be x minus 20, and whenever it's less than or equal to 20, the z value will be 0. So this is the function. It's not very straightforward, but this is the function, and we have to find out the expected value of z. Right, again the same formula, summation over all values of xi belonging to the sample space of x. Okay, the function of x that gives us z into the PMF of x. PMF is given, the function is given. It should be straightforward. Let's do it. So for all x less than m, the function gives 0, so we don't even have to write them. Okay, so we only write whenever x is greater than m. That means whenever we used the subscript k to write the PMF, so we'll just use k here. Whenever k is greater than 20. So it goes from 21 to 48. Okay, these are all the possible values. Remember, x can take all possible values. N is 48, so x, the possible values of x are 0 to 48 basically. Okay, and then the function for whenever k is greater than 21, the function gives us just x minus m. So that will be just k minus 20. Okay, and then the PMF of x, which is here, right, binomial, which is 48, and then k 1 by 3 to the power k, and 1 minus p, which is 2 by 3 to the power n minus k, which is 48 minus k. Alright, if you do this math, you'll find out the answer is 0.182 or 18.2%. Okay, thank you very much.